guys, welcome back to Swat Studs. Today we are going to look at creating something which I have showed you a while ago. If you remember, I have showed you a mirror illusion render and asked if anyone can figure out the method by which it's rendered. Most of you may have thought about doing it in a compositing software, but the challenge was to render the effect in a single render. Some of you have got it almost right. The answer I got was a Rayswitch shader. Well, yes. It was done using a Rayswitch shader, but that's half the answer. The other half was trace sets. So that's what we are going to look at today. We'll be looking at the basics of Rayswitch shader, how you can use it to create some interesting renders, as well as how it can be used for reducing render time. Then we'll look at the trace sets, how it can be used along with the Rayswitch to create also some interesting renders or some rendering effects. And in the end, I'll show you using these two techniques how you can create the mirror illusion which I rendered. So let's get started. So we are in Maya and we have a basic scene setup in which we are going to look at the Rayswitch shader. So you may have seen that we have in render settings the sample settings and the ray depths with which we can control how much indirect rays that can be calculated in the scene. Also, we have the same kind of setups in the Arnold lights here with which you can adjust the amount of indirect rays that can emit from that particular light. So we have control for each rays separately in each light as an Arnold control. So the Rayswitch shader is somehow works exactly like the controls on the lights or in the render settings, but it is for shaders. So with Rayswitch shader, we can use separate shaders for each kind of rays, so that if we need to control the indirect bounces of particular ray into a separate intensity or to a separate color, you can adjust that with the Rayswitch shader. If I talk more about the Rayswitch shader theoretically, it won't be enough for you to understand these things completely. So let me just go straight into showing you what I mean by this. So I have a simple setup here. I have a ball which has a simple a standard surface shader. I have created a color of a red color for that ball, and the plane is simply a white plane, and I have a dome light and a directional light as a lights. So let's first render this and see what we are getting with this. So we have a simple scene here, and I have added the denoise optics for getting faster outputs, and also I have added this basic render AOVs. First, let me create an Rayswitch shader. For that, I'm going into the node editor and I'm creating an airayswitch shader here, and I'm going to add the Rayswitch shader to the surface material of the shader group, which is assigned to the ball. So by default, when I'm assigning a Rayswitch shader, you can see it has different types of rays, which is camera rays, shadow, diffuse reflection, specular reflection, etc. So we can connect different shaders into each of these slider attributes, so that each of these rays will see those particular shader and will result the render with respect to which ray it got hit by the particular light rays. So if I am changing the color into white, you can see it becomes a white color. So you can also use flat colors as well in the Rayswitch shader, but first I am going to add the ball shader onto the camera. So let me just update the render because this is not the updated one. So you can see for camera rays, we are getting the red color, but if I am adding, let me save this render, and again I am going to add back the ball shader once again to the surface material of the shader, and let's see what's the difference between these two renders now. So as you can see, there is some indirect which is missing from when we were rendering with the Rayswitch shader. It is because we have not assigned any shaders into these diffuse reflection or specular reflection attributes, so that because the attribute colors are now black, it's not showing any, or it is not casting any indirect lights. So if I am to connect back the surface material into the Rayswitch and connect the ball shader into all of the other shaders, you can see that we are getting the exact effect which was we were getting with the bold shader by default. So the fun fact is that we can use different shaders according to our need, right? So I'm going to duplicate this shader, and let's say I'm going to use the base color. Instead of red, I'm going to put a green color, and I'm going to use this bold shader in the diffuse reflection. So now you can see that the indirect diffuse has changed from red to green. So if you want to see this more specifically, you can see here now, like when I'm adding the default shader, the color which is casted from this ball to the ground is by default, it's a base color, which is red. And that is how naturally things are, like when light bounces onto objects tend to happen, like it bleeds its own color onto the nearest objects. So that's what we are seeing here right now. But if we want to, like, let's say use the same color in the diffuse reflection, and if you want to reduce the effect, you can see we can do that with the Rayswitch shader. So with Rayswitch shader, we are telling the render engine that it's actually realistically creating this much of indirect diffuse, but we don't need all of that information. We want to reduce this. So we can reduce the indirect with the samples by reducing the number of indirect bounces, or with the light diffuse value or the indirect value. But that will affect the whole objects present in the scene, right? So here we are particularly changing the amount of diffuse or specular in particular shaders. So we get more control with each shader. So that is something that gives flexibility to the artist to create specific render outputs which they need. So let's move on with this. So we were using, let me put it back how it was, and I'm changing the bold shader diffuse color into green. And let's go back to specular indirect. So currently our plane doesn't have any specular, so I'm adding any specular right now. So you can see in the specular indirect, the reflection of the ball on the floor is red. So because the floor is really white, that's why we are not able to see any of the reflections here. So if I reduce it, the base color to black, you can see the reflections. And also if I increase the IO bar a bit, you can clearly see the red ball is reflecting on the plane. So let me duplicate this again, and I'm going to change the color to now a blue color. And then I'm going to add this blue shader into the specular reflection. So you can see, even though the ball is red in color, the specular reflection is now becoming a blue, because we are connecting a shader which has a base color of blue into the specular reflection of the Rayswitch shader, which is assigned to the ball. So these kind of effects we can create with the Rayswitch shader. You can also try reducing the specular amount or the diffuse color, which will give you the desired effect you want. And now let me take it back to how it was, and I want to show you how the shadows work. So let's say I am adding the ball shader 1 into the shadows. Now you can see how the shadow which is coming from the directional light in the scene, we can clearly see the shadow line here in the ball shader 1, which is connected now to the shadow attribute of the Rayswitch shader. I am going into the geometry attribute. I am reducing the opacity. Let me just update the scene, and now you can see the shadow is completely gone. So with this method, you can adjust the intensity of that particular object's shadow within the airayswitch shader. That's how we can use the shadows. And this effect is also will be visible if we use transmission onto the shader. You can see even if you turn on the transmission, it will not cast any shadows and you can get the same effect. But opacity and transmission will take more time to calculate. So using these different shader attributes in each of the shader will take its own time to calculate in the render. So you will have to see how you can keep the render time in hand with doing all these kind of tests. So another thing or an advantage of these things is that when you have, let's say you have a floor which is more specular and you want to like more rougher floor, and if your base shader is also, let's say, rougher, so a rougher specular object which is reflecting on a rougher floor will always going to increase the render time a bit. So what you can do there is that you can use an AI Rayswitch shader and use a different shader on the specular reflection and change its roughness to a bit glossy so that it doesn't calculate much of that render time. But these things are still like experimental. I cannot be 100% sure that it is going to save you some render time or it's going to increase the render time. So you will have to test it for yourself to see like how the desired result is looking and how much render time does it cost you to get that desired result. So I'm just showing you options so that you can try and see if that gives you that particular result that's you are looking for. And the next thing would be the diffuse transmission and specular transmission. So till now what we've been looking is that the camera rays, which is what we are looking at with the camera angle. So any shader which goes into the camera will be rendered if it is in front of the camera, and the shadow will be used to control the shadows. Diffuse reflection and specular reflection is only for the reflections which is visible on other objects, or the object's reflection or specular rays which is casted onto the adjacent nearby objects. The diffuse transmission and specular transmission. So first we will look at the diffuse transmission now and see what is the change that it can create. So for diffuse transmission, I'm going to make visible a plane which I have created. So this is a simple plane which has a single side. It doesn't have any multiple faces. So I am going to assign this a subsurface shader. Since it has only single side, I'm going to turn on the thin walled option. And now I'm going to connect the bold shader into all the shaders, and I'm going to use the second shader. Let me delete the third one. I'm going to use the second shader and I'm going to add a blue color in the emission. And I'm going to connect this into the diffuse transmission. So basically the diffuse transmission is used to get the indirect effect which is visible through any subsurface materials. So that's why I added a subsurface scattering onto this plane. So let me render this and you can see the effect. So the ball is completely red here, but as soon as I add the plane in front of it, you can see the scattering which gets on the plane from the backside is a blue light. So if I turn off the emission here, and let me update this, you can see if I turn on the emission and the base color, it becomes black because we have added the shader into the diffuse transmission, which is currently getting visible through the subsurface scattering surface. So let me turn it back on and you can see it again. We are seeing the same effect. So if I move it again, you can see the shader which is visible onto the camera and also in the reflection are all the default bold shader, but the shader which is visible through the subsurface scattering or diffuse transmission is our blue emissive shader. So that's how you can manipulate shader which is visible through subsurface scattering or diffuse transmission using Rayswitch. And the last one will be specular transmission. Specular transmission is simple glass material. So let me hide the plane and bring back the first plane. And I'm going to put the subsurface weight to 0 and turn the transmission on. So now I am going to bring back the diffuse transmission to the default shader, and I'm going to put the bold shader 1 into the specular transmission now. So let's render and see what the results are. So currently the glass plane is behind the ball. Let me move it front and see what the result we are getting. So you can see as the ball is closer or overlapping the ball's color is changing into blue because we have added the blue ball shader into the specular transmission. So this is how you can manipulate shader rays which is visible to the render engine with airayswitch shader. So now that we have seen how you can manipulate and use the Rayswitch shader, and you have seen the basic way of manipulating this with the Rayswitch shader, let's see how you can manipulate rays with trace sets also. So for aiTraceSets, I have created a different scene. So the aiTraceSet is nothing but the thing used to link objects for different type of rays. So in lights, we use light linking to link a light to an object or break the link of the light from an object so that the light would not affect that particular object. So same way, we can use trace sets with Rayswitch shaders to include or exclude particular objects from particular type of rays of a particular object. So in here, if I render, you can see that these three balls are casting shadows into the cube or this box and also into the plane. So let me assign a different shader to the plane. Now, let's say I want the balls to cast shadows onto the plane, but it should not affect the ground plane. So what I want is I want to hit the ball's shadow on this cube object, but it should not affect the ground floor. So if I turn off the cast shadows here, it will turn off the cast shadows completely from all the objects on the scene. That's a limitation. So what we need is separate control of the shadows on each object. So for that, what I am going to do here is that I am going to select the shader of the geometry on which I don't want the shadows, and I'm going to assign a Rayswitch shader onto the particular object. So here I have assigned a Rayswitch shader and added the plane shader onto all the attributes of the Rayswitch shader for the ground plane. Now next, what I'm going to do is I'm going to add trace set names onto each of these objects. So here, if you come to the shape node of each of these geometries, you can see here an attribute called trace sets. Here you can add separate names for each objects, or you can use the same name like ball on each objects. So let's see what happens if I use the same name here. And now I'm going to create an aiTraceSet here, and I'm going to add the plane shader into the pass-through shader, and I'm going to add the trace set name ball, which we have assigned on each of these balls, onto the trace set attribute. And I'm going to remove the inclusive check mark here, and I'm going to assign this onto the shadow. So let's see what happens if I render this now. Let's update the scene. So what happened here was it's not into the shadows, which we should be adding the trace set. It should be onto the camera. So let me add the default shader onto the shadows and add the trace set we have created into the camera, and you can see the shadows are not getting affected on the plane now. This is how you use trace sets. So in another case, let's say here we used the trace sets to call on geometries which have the trace set name ball and exclude all the shadows of those particular geometries which is casted onto the floor. Same way you can exclude or include reflections as well. So for that, what I'm going to do here, I'm going to use the same shader. So I am going to assign this airayswitch shader onto the cube here, and you can see now the shadows are gone. So let me reassign the default shader onto the plane, and I'm going to change the material a bit. I'm going to make it a bit reflective so that you can see some reflection. And what I am going to do now here is that I am going to add the exclusive trace set onto the specular reflection. So I had to create the file again because the file got crashed. So we were talking about creating or excluding particular objects, reflection from objects with trace sets. So if I render this now, we were doing this with the trace set. So usually we can use render status and remove, sorry, in Arnold, if you turn off the specular reflections, that will remove the reflections, but you can still see that there is a black details which is still there, which gives the reflection shape of the ball in there. So what if we have to completely remove that reflection from there? So how we have done this with the shadows, we have created a trace set which in the name of a ball, and we have given the trace set name to the particular ball which we need to exclude the reflection from the ground or the cube shape, and we have created a trace set, added the default ball shader onto it, and we have added the trace set name here, and we have turned off the inclusive type. So I'm going to add this into the specular reflection. So if you see here, nothing has happened because the trace sets or the way the Rayswitch works, it is a bit difficult to understand. You can't find any tutorials regarding these kind of informations on the internet. Even I did check because I was also confused, like it was supposed to remove these reflections like how we used to see, because when we added it into the shadows and turning down the opacity was reducing the shadows, it was removing the shadow information from the object. So likewise, it should be removing the specular reflection from that particular object of the specular reflection of the ball from this particular cube. Then I just experimented with adding it into another attributes and found out that if we add the trace set into the camera, that completely removes the reflection of the ball from that particular object. So right now I can't tell you what exactly is the theory behind it. Because of that, I am not going to explain how it is because I cannot explain it. The best thing to do or understand this is to test it with adding or removing the trace sets on each of the attribute and seeing what results we are getting. This is how we are able to remove the reflection completely of the ball from the cube geometry. And if you are wondering then why there is a or what the specular reflection will do in the ray types. So for that, I will show you another example. Here I have duplicated the cube and placed it in here, and let me, if I render this, you can see the reflection of the ball in the adjacent cube shape. So you can clearly see that even though this object doesn't have that specular reflection here, you can clearly see that the same ball has specular reflection visible in the mirror reflection of the scene. So if I am about to add the same trace set into the specular reflection, let me just update the scene. Okay, so currently what I have done is that I have added the normal shader into the camera shader so that we are getting the reflection back. Let me add it into the specular reflection as well. So you can see that the reflection of the ball is present in the scene, and also the reflection of the ball is present in the reflection of this image as well. So if I am to add the trace set into the specular reflection, then the reflection of the ball in the cube is completely gone from its reflection in the adjacent reflective plane. So that's where the specular reflection of the this shader's Rayswitch attribute works. I would suggest you experiment more with the Rayswitch and the trace sets to understand it better. For our time being, this is only a beginner class, and my intention is just to make you understand or show you how the workflow is. So this is all that we are going to look at about the trace sets. And one last thing that I want to tell you is that suppose we have multiple objects in the scene and we need to create multiple trace sets for each objects, as well as we need to create trace sets for, like, let's say 2 objects together. So how can we create those kind of trace sets? So for that, we will create empty sets in here. Like if you right click on the outliner and go to set and create set, you can create empty sets here, or else you can create sets from the create menu as well. And I'll say set balls 1. I'll name it balls 1, and I'll add the first 2 spheres into the set ball. Let me just remove the sphere 3 from this, and I'll just add sphere 1 and 2 here. And on the set ball attribute, if you come to the Arnold, you can see that there is an option to add overrides or override attributes into the particular set. So I'll click on the add button and I'll see if I can find trace set in here. So if I type AIT, maybe you can see you can find an attribute called aiTraceSets in here. So if here I am going to name it, let's say balls underscore 1, and let me create another set just like this. And I'm going to name this balls 2, and I'm going to add the second and third balls into the set balls 2, and I'm going to add the same attribute in here, and I'm going to name it balls underscore 2. So now if I add the set balls underscore 1 attribute in here, before that I'm going to add the specular reflection, the default shader into the specular reflection, and I'm going to add the aiTraceSet into the camera so that we can see the reflections going off from the objects. So I'm going to change the trace set name in the trace set node to bolts_2, or let's say, let's start with bolts_1, and let's see how it behaves. So you can see that one of the bolts now has no reflections. So currently what is happening is that since the second sphere is coming in both of them, it's maybe having trouble to calculate which one to include and which one to exclude, or which trace set name should it assign to this particular sphere. So to avoid confusion, I'm going to remove this from the set so that it works properly. So now you can understand, like, you cannot create multiple trace sets with the same objects added. Arnold gets confused with it. So we'll have to find another way if you want to include a single object into different trace sets. So that is all that we are going to look at in this part of the tutorial. And I hope you have at least basic understanding of how to use airayswitch as well as aiTraceSet to create some beautiful, interesting renders or render tricks. So I hope you'll have fun with Rayswitch and TraceSet shaders. So this is as far as we'll go in part 1. In the next part, we'll see how I have created the mirror illusion render using the techniques that I've just showed you. Thank you for watching this video. If you like what you watched and you think it was helpful, please help me grow my channel by liking the videos, posting your thoughts in the comments, and subscribing to my channel. Also, check out the other Maya and Arnold lighting and look dev related videos in the channel. You will find tutorials which are suitable for beginners as well as advanced level artists. Share it with your friends and groups as well who are also interested in lighting and look dev. I'll see you with the part 2 pretty soon. Till then, this is Swat signing off. Bye.